This lesson is on the basics of scientific notation. Your foldable should be folded like this, where everything gets folded in and the inside is completely blank. We will write in that in just a moment. You can go ahead and leave the foldable at the bottom and pause the video to write down the things I've written at the top of my page in my interactive notebook. And then once you have written this down, you can unpause the video and I will walk through this with you. Okay, so you should have written all of this down. Scientific notation is just a way that we write very large or very small numbers, and it looks like this. This is an example, 1.36, or this is really saying 1 36 hundredths times 10 to the 8th power. That's scientific notation. That is a very large number. We have two pieces to our scientific notation the way it's written. We have the digit, which you see in green, which is this whole 1 36 hundredths. The digit must always be between 1 and 10. It's got to be bigger than 1, but less than 10. And then this power of 10, this whole 10 to the 8th, is, like I just said, it's called a power of 10. Every scientific notation will have the times 10, and then there'll be an exponent. This exponent tells us how far we're going to move our decimal point if we're converting to standard form. Big numbers will have positive exponents like this. This is a very large number. And then small numbers will have a negative exponent like you'll see in just a minute. Okay, so let's go ahead and start in the foldable. Make sure you're in the 1 flap. We're going to write 1 35 hundredths, times 10 to the 5th power in standard form. Okay, so we know that this is the same as saying 1 35 hundredths times, well, 10 to the 5th is actually the same, 100,000. Okay, so you can put the dot or the multiplication sign in there. All right, so in order to transfer this into standard form, I'm going to move the decimal to the right, the number of times the exponent says. Okay, so it was 1 35 hundredths times 10 to the 5th power. How many times am I going to move the decimal? 5. So I'm actually going to go from the decimal point to the right, because it's positive exponent, 5 spaces. 1, 2, 3, 4, and 5. And then what am I going to do inside those swoops is fill in your zeros and rewrite your answer. 135,000. Okay. Swoop it, turn it around to number 2. We're going to write 2 7/10 times 10 to the negative 3rd power in standard form. So here's our negative exponent. Well, we know that this is the same as 2.7 times 1,000th. Okay, so we're going to move the decimal to the left, because it's a negative exponent, the number of times the exponent says. So we actually have 2.7 and it was times 10 to the negative third. I'm going to the left, how many spaces? From the decimal point, I'm going 1, 2, 3, and putting my new decimal point down. Fill in your zeros, and then rewrite your answer. So I have 0.0027, and most of the time you see it with a 0 in front of that decimal point, and that's your final answer. Number 3. Now we're given a number in standard form, and we're going to write it in scientific notation. So our rule for this, we're going to move the decimal to make the digit between 1 and 10, has to be somewhere in between 1 and 10, can't be smaller than 1, can't be bigger than 10, okay? The exponent is the number of times you moved, okay? So we have 67,800,000. Well, where is my decimal right now? It's behind this last 0. I need to make the digit be between 1 and 10. So I need to move it all the way over here. So my number is then 6.78. Well, how many spaces did I need to move that? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 spaces. I moved 7 times. And then rewrite your answer. My new digit between 1 and 10 is the 6 and 78/100ths. And now I need to write it times, and I need a power of 10. 10 to the, how many times did I move that decimal? 7 spaces. 67 million is a large number, so it gets a positive exponent. And then number 4, we're going to write a very small number that's given to us in standard form. We're going to put it into scientific notation. We're doing similar things here. You're going to move the decimal to make the digit between 1 and 10, and the exponent is the number of times you moved. Okay, so our number was 0. Let's see, 1, 2, 3, 4. There are 5 zeros, 453. That is a very tiny number. My digit then is going to be where? Where does my decimal need to go? Do I put it after the 5? This would then read 45.3. That's not between 1 and 10. It needs to go in between the 4 and the 5. Let's see how many times I had to move my decimal. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Rewrite your digit is now 4 and 53/100ths, but scientific notation has a power of 10. So times 10, well, to what power? There, I moved 6 times, but this is a very small number, so it is a negative exponent. It was smaller than 1, so it got a negative exponent. Okay? And that foldable can get glued down on that right-hand page. Your left-hand page was given to you. It's this one right here. Okay? So what I want you to do I'm going to do one with you in each section, okay? And then we will finish the rest for homework. So let's do number 2. This is a good one, okay? So number 2, a light year is a whole lot of miles. How many miles are there in a light year in scientific notation? All we're doing is writing those numbers either in scientific notation or standard form, whichever it's asking for. All right, well, I know to write it in scientific notation, I had to put my digit to be between 1 and 10. So my digit, my decimal is going to have to go from back here at the end all the way up to be between that 5 and the 8. So it would read 5 and 88 hundredths. And there will be a power of 10 to account for all of those place values that I'm going to move. Okay? So let's see how many times we had to move. We need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so it's going to be times let's rewrite the digit first, actually. My digit was 5 and 88 hundredths times my power of 10 to we moved 12 spaces. But is it a positive or a negative? Should be positive because that is a large number. Gets a positive exponent. All right, good. Let's do one in the bottom. Okay, let's look at number, 8. Let's look at 8. The population of India as of July 2009 was 11.66 times 10 to the 8th people. Now my directions say decide if it's written in scientific notation or standard form. If it's not in scientific notation, explain how we know, and then try to write it in scientific notation. Okay, so this looks to be like it's in scientific notation, but it's actually not. No, it's not in scientific notation because the digit is not between 1 and 10. I actually need to move that decimal over one more time. So my digit should actually be 1.166 times 10. Well, if I move to the left again, I need to change that exponent to be a 9. And that's my answer. The code word for this video is, I don't know, this is not fun. Pencil sharpener. Let's do that. Pencil sharpener is this code word. Go ahead and you can have both of those signed for points for extra credit. Do not glue this on your left-hand page. This is going to turn this in, and I'm going to check for your understanding. Okay, you'll turn that in when you get back to class. And then once I give it back, you can glue it in. If you have any questions, please feel free to send me a remind message or an email.